Hello everyone. So today we are going to discuss about air masses and fronts. First of all, what is air mass? Air mass is that mass of air which have same temperature and humidity. A chunk of air which have same humidity and temperature. Let's say we are at equator. Then we are trying to find some amount of air that is having same temperature and same humidity. Uniformity should be present over there. Next is we are going to do the classification of the air masses. So classification of the air masses is done on the basis of mainly two criteria here we have taken: continental one and the maritime one. For continental we have tropical, and we also have polar. Similarly, for maritime air masses also we have tropical and polar also. Moving on, we are going to discuss about these type of the air masses. First of all, we are going to look into the continental polar air masses. So continental polar air masses mostly found in the regions of central Canada and Siberia, in the latitudes which are near to the polar latitudes, and a very high cold climate would be found here. It is mostly dry because it is continental. So whenever we are going to see the continental air mass, mostly there is probability of them to be dry, because moisture can only be attained by the air masses when they are marine in nature. Maritime air masses would have water moisture more. So that's why we are going to see it. It is extremely cold. Stable Instability arises more when it is moisture containing. So there is more probability of it to be dry and to be stable. So no clouds in these air masses and can be found in the central Canada and the Siberia region. That these regions, this is maritime polar in these regions also. Maritime polar. So in the ocean regions we can find this. And next we have is maritime polar air masses. So if it is maritime, then definitely it would be going to have moisture, but this moisture amount will vary, as polar regions would be having ice also, so it is hard to get the moisture in case of winter. So we have moist, but we have few moist clouds. But in case of summer, we would have cool and moist in even lower parts. Yeah. So high altitudes, there is probability of getting the moisture containing air masses, and that's why we can have precipitation too. Lower layers would definitely be moist and unstable. If it is moist, then definitely it is unstable. If it is dry, then it would be stable. We would call it that it is stable. So that's why we can see that if it is maritime polar air mass, then there is probability of getting moist clouds. Looking in here,
That these
that we
reasons.
can find the
This is maritime
maritime polar.
polar
It means here in this region,
in
and also
these
here
regions also.
we can find it
Maritime polar. So in the
here also
ocean
maritime
regions we
polar.
can find this.
So this is where it can be found. The next one is continental tropical air mass. If it is continental tropical air mass. So continental tropical air mass is found in the subtropical regions, and it is continental. There is less probability of it being moisture containing. But in the equatorial regions, as we receive very high rainfall, then even in the continental part, we can receive uh, the moisture containing air masses. So that's why a temperature would be high. Definitely in the tropical regions we have high temperature, but there would be moisture less moisture, but still we can expect some moisture. If moisture is there, it means instability in the atmosphere. What does instability implies? It implies that we would be having rainfall also. So stability in some upper parts, but instability in the lower parts of the atmosphere. In upper parts, there might be probability of getting less moisture and dry regions, but in lower parts, we can receive instability easily. The next we have is maritime tropical air mass. Maritime, then definitely moisture containing. Tropical, it is in the region of the latitude of 0 to 30 around. So warm and moist. Moist means unstable, and definitely we can expect it highly unstable. Very much high precipitation would be observed. Looking in the map now. Now we have this South America. So we are going to see in the tropical regions. So this region continental tropical, this region continental tropical. So here we can have maritime tropical, and here also maritime tropical. Yeah. The next one is fronts. First of all, we are going to see what is fronts. Fronts imply that it is a point where two kinds of air masses would be mixing. So let's say some cold air mass is there and some warm air mass is there. And if these air masses are trying to get mixed, then it is lead to the formation of fronts. There are various kind of fronts like cold front, warm front, stationary front, occluded front. Moving on, we are going to discuss this what is cold front. So cold front means that there would be two type of air masses present here. So what are those two type of air masses? The first one is cold air mass and the second one is warm air mass. So let's say from this direction, cold air mass is approaching. Cold air mass. And from the other direction, warm air mass would be approaching. So we can say from this direction, warm air mass is approaching. At the point of their meet, let's say this is the point. At this point, the cold air mass would be forcing the warm air mass up. So this is the point where the cold air mass would force the warm air mass to rise up. So by this sign we can indicate this that this is the direction of approach of the cold air mass. Cold air mass is approaching from the back side and asking this warm air mass to rise upwards. If the rise of the warm air mass is by the external force of the cold air mass, then this is cold front. And in case of cold front, what we can see is it is a vertical rise up. So we can see clouds would form here and a very high rainfall would occur. The next one, and now the warm front. In case of warm front, we have the warm air mass and the cold air mass both. So this is our warm air mass which is approaching from this direction, and from the other direction we have the cold air mass approaching towards this point. So from this direction we have the cold air mass approaching. This is cold air mass. But now in case of warm front, the cold air mass do not have to provide some force for it for raising it up. Now This warmer air mass will rise up on a gradual surface. This rise will happen, and this also lead to formation of clouds, but the rainfall would not be as much high as in case of the cold fronts. Cold fronts lead to very high rainfall, but this is slower than that. Next we Next is stationary front. Stationary front is observed most of the times when we have the warm and cold air meeting each other, but the condition is that the pressure gradient and the temperature gradient is very less. Warm air mass from this side, and if it is approaching from this direction, we can say this would be formed. But then next we have is cold air mass, and let's say cold air mass is approaching from this direction. This is colder one. For colder one, we can say this would be made that this is approaching from this direction. So both of them would be approaching from each other side. Due to the moisture present in the warm air mass, clouds would be formed here and rainfall would occur. But the main important condition we have here is that there is very less pressure gradient present here. So due to the less pressure gradient present here, we would not be observing very strong rainfall in this region. Next one, here warmer air mass would be coming from one side and the colder air mass would be coming from another side. What happens is colder air mass would try to overtake the warmer air mass above. But in the beginning, warmer air mass do not rises up. That's why we can see that here occluded region would be formed, where warm front would also be defending when the colder forcing it to rise above. So we have colder air mass downside. This is our colder air mass, and we have this warmer air mass above, which is defending the motion. Colder air mass exerting force from this direction and warmer air mass is also exerting force in this direction. That's why it is very hard for colder air mass to raise the warmer air mass above. As the density of the warmer air mass is lesser, then it should rise, but it takes very long time for it to rise completely. And when it rises, then we can see that some this kind of structure would be formed. We have colder air mass at the surface. This is colder air. We have colder air here also colder air mass. But above we can see that hot or the warmer air mass would be found. This is how the temperate cyclones also work in this way of the occluded fronts. So in temperate cyclones also the warmer and the colder air mass competes with each other in overtaking each other for rising up. I hope you understand the topic well. Thank you for watching.